Welcome students. Today we will discuss about uniformly accelerating systems. Last class we have discussed the Galilean transformation where it relates the coordinates and velocities between a rest frame and an inertial frame. In this lecture, we will learn if the second frame or the moving frame is not inertial but it is non inertial, which means the second frame is having a velocity which is moving, which is changing. That means it is having an acceleration. This slide shows the Galilean transformation equations, whereas the alpha is the rest frame and beta is a non-moving frame. So accordingly, we just subtract the displacement and velocity or acceleration from the corresponding values of the rest frame to get the values in the moving frame. Now, you come to the acceleration. The acceleration A beta is A alpha minus A. That is, capital A is the acceleration of the second frame. Suppose if the acceleration capital A is not zero, then the force measured in the second frame will be ma, the force measured in the first frame, minus m into capital A, which is not zero. So the apparent force in the second frame or the accelerated frame will be lesser than the force measured in the rest frame. This difference in force, that is minus ma, so the that means the difference between the force in the rest frame and the fictitious force, that is m capital A, that is the force which is observed in the moving frame. Now, the fictitious force is defined as minus of mass into acceleration of the frame. So what is fictitious force? Fictitious force is a apparent force which is experienced in an uniformly accelerated system, and that is proportional to the mass of the body and acceleration of the frame. For example, if I have a car moving in acceleration A, there is a pendulum inside the car, and let us find the angle by which the pendulum makes with the vertical. So in this problem, if we measure this from an inertial frame, that is first frame, then you are looking the string or the pendulum from outside the car, and the car is accelerating in the x direction, and the force diagram gives you in the vertical direction the components of the force are t cos theta along upward direction, vertically upwards, and w weight along vertically downwards, but both are equal and opposite, they cancel out.
We conclude that from the point of view of
in the horizontal direction
behaves like a
the
horizontal gravitational force. That means
t sine theta is the tension which is acting in the direction of minus x, and capital MA is the acceleration of the car, and the mass of the capital MA is a mass, and that will give you t sine theta is equal to MA. If you just divide the two equations, you will get tan theta is m capital A by W, or else capital A by G. From there you will get the value of T. Similarly, if you do the same calculations, assuming you are sitting inside the car and measuring the tension, you will get the same value of tension. So we conclude that from the point of view of a passenger in the accelerating car, the fictitious force behaves like a horizontal gravitational force. That means normally gravitational force is vertically downwards, but for a passenger inside an accelerating frame, it behaves like a horizontal gravitational force, because the body inside the accelerating frame experiences an opposite force
just
a
write
force
the
opposite to the direction of the acceleration.
force equations.
Therefore, the effective gravitational
Actually,
force is the
a
vector sum
small
of the real
experiment
and the
fictitious
fictitious
force will give
forces.
you. So the force that is
If you
measured in
want to
the moving
imagine
frame
what will
from
be
the
the
moving frame, it
helium
will be equal to
balloon,
the
if
force
you
from the
put
inertial
instead of a
frame
stone,
minus
if you put the
fictitious
helium
force,
balloon, what will happen
and that is
in the
F
accelerating
minus
car?
small
Therefore,
f
we
is
come to the conclusion that the inertial,
force of the
sometimes the
inertial frame minus
fictitious
F
force is also called
fictitious
as
force is
inertial
equal to
force.
capital A dash.
That means it doesn't arise
Accordingly,
from
we
the
will get the
physical
value of the
interactions.
acceleration
It is just due to the motion
of
of
the
the
cylinder
frame. It
of
behaves like
the
a gravitational force,
moving
and it is
frame,
proportional to the mass and the acceleration of the
and the acceleration
frame. The
gravitational
second
force
example is
of
a
1
cylinder
1 by
rolling
3
without
meter.
slipping in a
So
plank.
from
If the
these
plank is
things, we
also
come to
moving
the
with an acceleration
conclusion that
a,
there is a
and
force
the rotational equation, if
which
you
is
just
acting on
calculate
the
the
body due
torque
to the acceleration of a frame, which is called as
and the force,
fictitious force.
so if you want to find the acceleration of the cylinder, just write
Welcome,
the
students.
force
Today we will
equations.
discuss